So I'd like to talk to you today about clouds, because I think clouds are cool. They're just drops of water suspended in the air. They don't really have any substance, or they're not really a cohesive unit, but they form these beautiful shapes with so much variety, and they contain so much power. Unfortunately, I can't talk about these clouds all day because this is a lightning talk. I think that's the worst pun of it. We're past it now. So let's race through the introductions. As Kirk said, hi, I'm Petra. I'm from Aura Information Security. I'm a virtual security officer there. We fight evil. We do have some senior vacancies at the moment if anyone is looking for work, just quietly. I'm also into ticking the I have had contact with wildlife box on airport arrival cards. That's dingo. The customs officer was not as impressed as I was. And I pick locks and teach other people to pick locks for fun. So with that out of the way, let's get our head in the clouds. Okay, that's the worst pun of the talk. So this is what I would like to cover with you today. This talk is for you if you haven't moved to the cloud yet, or maybe you're dabbling with it and you're thinking of moving your applications or business computing to a cloud environment. We're going to look at what the cloud is, but more importantly, how you can secure it. A little spoiler for later on. So let's start with what is the cloud? Now, some people will tell you the cloud is just other people's computers, which is true in the same way that the other clouds are just water. It's a different model of computing from the on-premises or data center computing that you were used to. It is a virtualized infrastructure that gives you access to storage, connectivity, processing power, functionality on demand on a pay-as-you-go model, which makes it incredibly flexible and scalable. You just have access to all of these environments and resources and services, and you can just pick the ones that are right for you for what you want to build. And of course, this great flexibility also introduces great complexity. So there are different models of the cloud, and it's really important to note this. We call it infrastructure as a service. There's a model where you just have access to some space to put things, connectivity, a network, and you put your entire apps and all of the configuration you want in there. There are also options that are increasingly popular. Sometimes it's called platform as a service, or you might hear it called serverless, where the underlying infrastructure level of databases and things like that are there available for you, and you just bring your app. And there are also, you're probably all familiar as users of software as a service, the model where you don't even have to bring your own application. You have that all provided for you. It's, you just bring your data. So this talk will touch on all of these different models, but it's important to know that the cloud gives you a lot of options for how you use it. So this is, I think, the message that I want you to take away about how the cloud is different. It's about not a machine you have, where if you want more of a certain thing, you have to go out and buy more RAM, buy more storage space. It's not about a thing you have and look after. It's about what you can do. So, with that said, is the cloud secure? Now, who remembers the spoiler from the introduction slide? Yeah, the answer to this being, it depends, yes. So, if you go to a vendor's website, they will have this lovely page saying, our cloud is secure. Our data center has got this certification. We have this PCI little tick icon. Yeah. they're secure. Saying that your cloud environment is secure because the data center has certification is like saying your on-premises network is secure because you've got good locks on the cabinet. I mean, it's a good start. It is part of your complete security breakfast. But if some miscreant has been teaching everybody in the office to pick locks, then maybe it's not enough. There's more to security than that. So it really does depend. So let's maybe ask a different question. Okay, this one might be a little bit too abstract. All right, let's start here. Who's responsible for security? And the thing is, if you're moving your app, your data to a cloud environment, it's not as simple as saying, I'm putting this in someone else's system, they're responsible for it now. So security at its heart is about establishing trust in the environment. In a traditional setup, you're on premises, your data center, it's kind of clear who's responsible for achieving that. It's the person who can touch the box. It's the person who can get in there and actually do those things. Someone controls that environment, and that person or organization is the one responsible for keeping it secure. Pretty easy. So this would traditionally call this something a perimeter model for security, because it starts with a nice ring-fenced, here is our environment. Here are the bits that we have the locks and keys for. Here's the bit that we can touch. Here's the bit we control. And so you've got your physical environment, you've got your office space or your physical site, you've got your hardware, and you've got your network, and you've got the operating systems that you're patching, keeping nice and up to date. You've got your nice secure application there with some really good secure development going on at that layer. You've got your access controls and your excellent password policies, and everyone's using good passphrases. You've got the endpoints, the users, and the devices they're using, and you're keeping them secure. And of course, you've got all of the rules around what your data is and who can do things with it and where it can go, your classification and your data flows. So pretty traditional, pretty familiar to most people. This makes it secure, right? So the cloud, we don't have that level of control over all these parts, but we still have all these parts, and so we need a different model to keep it secure. So instead of a perimeter model with a big border around it, we have something called the shared security model, the shared responsibility model, which, as the name implies, means that responsibility for who secures your environment is shared. And it's normally done on a basis of somebody has responsibility for each one of these bits. And that part is really clearly defined. It's in the contract, it's in the documentation, so you know what you have to do, and you know what the other person has to do, and they know what they have to do. So in your infrastructure as a service model, the orange is not an endorsement for any one particular brand, by the way, it's simply a nice contrast. You've got your physical environment, that data center that's got the little tick on the website telling you how secure it is, and the network, there's probably a firewall in front of that. And then you've got a virtual machine where you're putting in your operating system and everything that sits on that. Your serverless model, they're taking care of this, and actually probably part of that application stack. So again, you have clear agreement for who's responsible for what, so that it's no longer one person, but there's a clear agreement that both of you know who's doing what. And then there's the SaaS model, so your Gmail or your Dropbox or whatever, where you don't have to actually create the application yourself. That's being provided and that's being secured by the cloud provider. But you notice that even with this model, there are certain parts here that stay blue, because there are certain parts that you are always responsible for. You're always responsible for who you're allowing access and what you're allowing them access to. You're always responsible for those classification rules about what data is allowed in this system and where it can go. So even with the highest level of outsourcing parts of your security in these clouds environment, there are still parts that you have to do yourself. So how do we keep a model that looks like this or this or this secure? How do we stay safe in the cloud? So security in the cloud is, it's about, you still have responsibility for securing the things, for the security of things, even if you don't have responsibility for securing the things, which I know sounds like a nightmarish double bind, but it means that it's your data, it's your project, you are responsible for the decisions, for choosing the provider, for making sure that they have the ability to do what you need them to do. Which sounds very, very daunting, but it isn't so hard to manage your security risks if you build these decisions into the specification of what you are moving to the cloud. And so we need a plan. So the first step of a plan to keep your data secure in the cloud is you need to know what it is you're securing, what it is you're building. The better understanding you have of what you're building, the easier this is. So what are we building? Are we building a web app? Are we moving our entire corporate structure with our CRM and our enterprise management system, or is it just going to be one quite discrete thing? And what is it going to interact with? Does it have to connect to other systems on our own premises, elsewhere in the cloud, perhaps in a third party? So knowing where the data has to go, being able to map that, the data flows, know who's allowed to see what, will make it much easier to build a secure product. What do we need to protect? What have we got that's sensitive? Have we got health data? Have we got credit card details? Have we got information in there that's really sensitive? Are we building an app that is going to be used by people like the application that was discussed in the threat modeling workshop in the morning session, where it might have some information that could be very damaging about the people using that app if it got out? If you do ask these questions, work out what your threats are, you can specify the kinds of security controls you need, the level of controls you need. And it's really important to really look at your organization and say, well, what resources do we have? So with these different levels, these different models, this platform as a service, infrastructure as a service, software as a service, there's no point making the decision just on the dollar value of what that cloud product's going to cost you. If you don't have people in-house, you're quite possibly better off going with the SaaS product than trying to build your own because it would cost a little more than the infrastructure version. So sometimes it is, in the long run, more cost-effective, better security to acknowledge when you don't have the in-house expertise, in-house resources, in-house time to manage that and actually use a model where that is outsourced to the provider. So the next step, now you know what you're going to build roughly, you know what it needs to do from a functional perspective. Go do your homework on the provider, read the docs on their website. Can they physically do the things you needed them to do? And also all of those privacy policy things, is there a clause that, yes, we're actually also going to be selling your data for marketing purposes, and are you okay with that? So do some passive information gathering. Don't just take their word for it. Talk to other people. Google them. Have they had an incident? It's 2019. Everyone's had a breach. The important question now becomes, what happened next? What did they do with that? Did they pretend it didn't happen and claim that there was no breach, this was just dirty hackers, they were wrong, they shouldn't have done it? Or did they actively take steps to remediate that? Because ultimately that's what is going to matter, is how places respond. And then once you've found a provider that you're pretty happy with, you're okay with the level of capability that they seem to have to meet your needs. They seem like they're onto it people. Go and actively quiz that vendor. Go get a questionnaire. The New Zealand government made the one that its government departments use. If you Google search for GCIO cloud questionnaire, you'll find a list of like 100 questions that they use. You can send to providers and say, do you do this? Do you do this? How do you do this? So it's a structured way of getting that information that you can vet their capabilities and work out whether they're right for your needs. And then negotiate. You're paying them money. They work for you. You might not have quite as much leverage as you might have over an organisation that you're contracting as a service provider in a traditional sense, but you can still say to these people that you expect, you expect a certain level of service, or that your data is not going to be sent to certain countries, or that you demand the right to be able to audit or pen test their systems. It's always worth asking to get that extra level of validation from them. And if there are gaps, if you find a provider, they're perfect 99% of the way, but there's this one thing they can't do, you might need to negotiate by finding another party to come in and be part of this mix. Often what happens is that there's no one provider that provides the perfect solution, and so you find 2 or 3 or more providers that offer parts of the solution and integrate them together. So it's important to look at these questions about how they're going to interact with each other to form the solution you need. So now we've got an idea of what we need to build. We've got a couple of vendors picked out that we're going to use to host and operate our cloud service. We have to build the thing. And that starts with people. It always comes back to people. And the provider you've got, providers, plural, possibly some other third parties in the mix, more of a service provider who can help you with things that you don't have the capacity to do in-house. If you don't have a full application development team to take care of the day-to-day things, like making sure that your backups are working and that your patches are applied. And then design what the solution looks like. Data flows, network diagrams. This is the stuff that when it's in-house, you can often get away with not writing, not actually designing it and just kind of doing it ad hoc because, well, I mean, you can walk over there and look. But it's really important that you, for a successful project, actually design this so that you can look at it, that you can find the gaps in it, and you can, importantly, when it's written down, you can get other people in that mix to have a look at it. So everyone is literally on the same page. So the providers know when you say, this is your responsibility, I want you to do this bit, they know what this bit is, how often they're doing their patching or whatever the requirements you have, their understanding and your understanding is the same understanding. And also when it's written down, you can share it with other people, like external party to help you to review what you're planning to design and give feedback on it. Often the big cloud providers like AWS and Azure will have people who are available to you to basically go through what you're planning to build and look at designs and help you to understand security issues that you might need to control for. So you've got that access to that expertise, and it's very hard to give them an idea of what you're building if you can't show them the documentations of it written down or drawn out and are instead trying to kind of describe it. So the more people you have in the mix, the more vital this part becomes. But we can't predict the future with our systems, no matter how perfectly we design them. People do try to predict the future with clouds. It's called necromancy. It's been going on since ancient times. So maybe we can do a bit of necromancy with the systems we're building too. Because security is not a set and forget activity. It's not a one-time thing. We need to build our systems so they stay secure in the future. And we can do that with reporting Traditionally, if you've got a third party doing some things for you, you probably get them to write some reports to you telling them what they've done on your behalf and check in with you. These are usually self-service in a cloud environment. You'll sort of pull out something like AWS config that'll give you a list of the things you have in your environment, the state that they're in. But you actually have to go and look at those and check for anomalies or find someone who can do that on your behalf. A little bit more active, so it's a bit more effort, but you don't have to remember to go and look at it. It can give you more real-time feedback. Monitor your environment for things that are not what you expect, things that are not what you want, so that you will know about them. Because although someone else might be doing something on your behalf, it's still your data, it's still your application, you're still responsible for it, so you've got to keep an eye on it. Testing includes things like penetration testing and other validations that those controls you think you have are working. They're there and they're working as expected. And keep your eyes on the horizon. Keep watching for new features that are available because these cloud environments are adding new features and tools all the time. So watch the news feeds and find out more for more features that might be useful to you or changes to the ones you're already using. So the takeaways from this, cloud security is a shared responsibility. It's not about control or about who physically has control of that, but it's about establishing well-earned trust. It's not set and forget. It is an ongoing commitment, and it is much easier if you have and carry out a plan. Do we have time for questions? We do not have time for questions, so you can just have a look at the pretty picture.